Hello, this video is for Smart and Hackathon 2024. My team name is Jeevan and our problem ID is 1585, which is development of portable EMI EMC induction measurement instruments. So what basically are EMI EMC and what does it actually mean? So whenever there is a high voltage appliance, it produces electromagnetic interference which can cause harm to some of the devices. This particular problem statement revolves around the EMI EMC interference for in the railway department. The NFC tags or other instruments they can get harmed due to the EMI EMC interferences. So these electromagnetic waves they consist of mainly two fields, which are the H field, which is the magnetic field, and it ranges from about 100 kilohertz to 3 gigahertz, and the electric field, which ranges from about 30 megahertz to 6 gigahertz. Now, there are several rules laid down by various institutions regarding the EMI EMC uh, capabilities of a device, and which should be limited because the devices are produced in such a way that they produce less and less EMC and EMI waves. EMC basically stands for electromagnetic compatibility. So, to measure these electromagnetic fields, there are usually enclosed chambers which the cost of making them is pretty high, and they are very precise in their activity, but the cost is very high and the equipment is not at all lightweight, or it is not at all portable, like it cannot be used by a normal person. It requires a specialized person. So basically what our proposed solution is that we will develop a portable EMI EMC machine that will help in detecting the spikes in EMI across various devices. Since it is portable, it can move to various locations and we'll just find out from where are we getting that sort of the barrier, the threshold for the EMI that it can harm other devices. So we'll be using an STM32 microcontroller as a brain of the system, and along with that we'll be using down converters and RTL SDR, which are the software defined ratios for signal processing. Now why are we using them? Because the H field and the E field, the frequency produced by these fields is so high that the STM controller cannot understand it and infer the quality information from it. Since the STM32 has limited programming speed and CPU speed, it has to be under that frequency. So that is why we will be using down converters, which will convert those high frequencies. They'll have the same data, but it will just tune them down to the lower frequency range, and it should support wireless data transmission for easier use and deployment, so that the information can be transferred to the local network operator or the department society. Now, how it addresses the problem that it being very lightweight and compact and no large equipment, it will be easy to be used by a non-skilled professional, as it will just give out the information. It will have advanced signal processing and some algorithms, home developed algorithms that will help determine the harmful EMI and EMC waves. It will be a cost-effective solution and more affordable than traditional system. Basically, we can like deploy an oscilloscope, but that oscilloscope will not have the capability to read the EMI EMC waves because, as I told earlier, they are of very high frequencies, not to be understood by the STM32 microcontroller directly. What our innovations are designed will also bypass the high skill requirement required to run the current EMI EMC detecting machines, and it will be able to be operated with by a semi/low skilled worker. And since we are using the RTL SDR and down converters, they are a very cost effective solution and sort of the innovation uniqueness for our project. So this is the technical approach. I'm sure you will read them in the PPT. So let's come to the methodology. First, we'll detect the signal, the H field and the E field probes. By the way, these probes will be detachable from the device and can be hot swappable. So we can change the modes and just get the relevant information. Signal detection, these probes will detect the H and E fields that will be converted, signal down conversion. It will happen by there are predefined like equipments made for them for the down converters and RTL SDR. RTL SDR is basically the software part. Will send this information to a local machine, it will process it and return it back to the STM so that it can be processed easily. The processing can also be done on the STM32, but it requires a little more time for processing, so sending it to a local machine via cloud will be a better approach. Then the data will be processed, the captured signal using advanced signal processing algorithms. The data will then be wirelessly transmitted to the railway operator or any other person that needs to monitor it. And it can also be stored via the ESP node MCU to the local data servers. These are the impacts and benefits. And this is the SWOT, the strength, weakness, opportunities and threats. The piece for the feasibility and viability. All this is present in a video. So just let me show you the working model, the simulation, that how we'll basically build the portable EMI MC machine. So I've used Proteus 8 for the simulation part. This will be a main microcontroller, which is the STM32F401VE. It has a 16-bit ADC, which is analog to digital converter, and it will be enough for the processing that we need right now. For simulating the down converters, I had to use like two different equipments, which are the LMF380, that is the low pass filter, and the AD663, which is the analog mixer. These are the signal generators. It will mimic the signal generated by the H field or the E field probe, and basically one signal that is generated from the H field and another signal that will be used for the down converters. This signal will provide that how low we need to get our signal to. So this signal is generated, it is inputted into the analog mixer. From that it refines the signal and it is passed on to the low pass filter, which further slows down the frequency, and at last it is sent to the ST microcontroller. From that the signal is now tuned down, the frequency is now understandable by the STM, it can easily process it. Just like a normal oscilloscope, it will have few pins for the I2C display and it will just project the signal produced over here. And apart from that, that will be for the more technical guy that who needs to operate it. For the simpler version, it will just give a red or a green flag for like if the signal strength, the EMI interference is too high or it is like under control. So that is it. I hope uh, this presentation and video made it clear what actually the project is, and thank you.